Okay, so problem number 2 says very plainly, although the measurements can never be exact, the lengths of the sides of any right triangle should satisfy the Pythagorean theorem. So I plugged the numbers in, and these numbers right here came from my table that I created, the one that that I wrote it down with on my, showed it on my document camera. But I transferred it. You know what? I can put it over here. I can do that. We got, this one was 8, and we got, this was 3.6. We got 7.3 and 3.3. We got 3.2, and we got 1.4, and it was 67 for both of them, and it was 23 for both of them. Okay, so we got those, and those numbers right there, I did a squared plus b squared equals c squared, a squared plus b squared equals c squared, because the hypotenuse is the c. And on this one, I got 63.53 is supposed to be equal to 64. Close enough. You round that up, you get 64. And right here, I got 12.85 is supposed to be equal to 12.96. So those are even closer. So yeah, I would say that we did okay on the measurement. So there's obviously some room for error. It says they're similar. Now find the scale factor. Now, to be quite honest with you, it doesn't completely satisfy. I don't know which one was considered my original. So that it says the scale factor of advertising logo links to corresponding. So that means I'm going to be changing the advertising into the corresponding letterhead. So I put the advertisement on bottom, the letterhead on top, and then reduce that down to a decimal, and it comes out to be about it's supposed to be a 4. It doesn't like me to write my 4s little. So it comes out to be 0.45. So obviously 0.45 is a decimal, a number between 0 and 1. So that means that I am reducing it. And as you can tell over here, it is a reduction to go from the advertisement to the letterhead. So that's seeming to be, accurate. Here they're writing the letterhead, they're writing the ratio differently. They're not writing it as, they're not writing it as a ratio. They're writing it side by side, which is absolutely something that can be done. But you just have to be careful here and know that the 2.3 goes with the bigger one and the 1 goes with the smaller one. So you have to pay attention. It says the scale factor of letterhead logos corresponding business card logos is 2.3 to 1. So this one is letterhead. So in other words, the letterhead is the bigger one, and this one is the business card. Okay, so 2.3 would be the letterhead, and then the 1 would be the business card. So if we know the business cards, we multiply it by 2.3. If we're trying to get it smaller, we're going to divide by 2.3. So determine the length of the business card. Okay, so the letterhead was, the hypotenuse was 3.6. So we've got to reduce this by 2.3. So we're going to say that the hypotenuse, this is of the letterhead. We're going to make a little table. And the business card, then the hypotenuse for the business card, if this one is 3.6, then take 3.6 and divide it by 2.3, and we get, this one will be 1.6. Okay, and you can double check and make sure. If you take 1.6 and multiply it by 2.3, you should end up with 3.6, and I got 3.68. So okay, so that was the hypotenuse. Then we have the long leg. The long leg on the letterhead was 3.3. So we've got to reduce that in size. So we're going to divide it by or you could say we're multiplying it by 1 over 2.3, which is the same thing as dividing it. So 3.3 divided by 2.3, and we get 1.4. And then the short leg for the letterhead was 1.4. So the short leg for the business card is going to be 0.6. Okay, use a ruler to draw the business card logo to scale in the space below. Okay, I don't have a ruler and I don't want to turn on my document camera, so I'm going to assume that you can take your ruler and draw that. The hypotenuse, remember, is 1.6. So we're going to pretend this is 1.6. This is 1.4, and this should be 0.6. It's actually going to be quite small because 0.6 is not even a centimeter long, so it's going to be a little bit smaller than that. Okay, so now we're going to go, it says she's trying to incorporate right triangles into as many of her logos as she can. She's noticing that some relationship exists. We're going to use these grids down here to draw the right triangle that has a longer vertical leg and a shorter horizontal leg. So the longer vertical leg, so that means that this one right here is 8 and the shorter one is 6. So if you have a right triangle, and we do, that has 2 legs that are 6 and 8, then because you've learned your Pythagorean triples, then you know your hypotenuse is 10. Okay, so a long leg is 5, and so the long leg is going to be vertical. They already told us that. 1, 2, 3, 4, 5. So the long leg goes here. The short leg is 1, 2, 3, 4. Then you connect them. That's the hypotenuse. This is 5 and this is 4. And this one right here is the square root of 25 plus 16. And that's 41. And I don't think the square root of 41 simplifies. So does it say to the nearest tenth? So we have to do the square root of 41. And that's 6.4 rounded to the nearest tenth. Uh-oh. I hit a button. This is 4. 1, 2, 3, 4. This one's 1, 2, 3. I don't have to calculate this one. I know this is 5. How do I know that's 5, people? Because it's a Pythagorean triple. It's a 3, 4, 5 triangle. My dogs are going berserk right now. Okay, so the long leg is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The short leg is 8. 1, 2, 3, 4, 5, 6, 7, 8. That means the hypotenuse is the square root of 100 plus 64. So the square root of 164, I'm using my calculator, is 12.8. So the hypotenuse is 12.8. That's about 12.8. 12 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the hypotenuse. This is 12 and this is 9. So the hypotenuse is 144 plus 81. That's about the square root of 225, and the square root of 225 is 15. Now, I didn't recognize it because it was a 12 and a 9, but if you look back now, this is 3 times 3, this is 3 times 4, this is 3 times 5. It's a 3, 4, 5 triangle, a multiple of the 3, 4, 5 triangle. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3. There's the hypotenuse. Uh-oh, I clicked that button again. I gotta quit clicking the button. My thumb is too close to it. So 6 times 3, that means the hypotenuse is 36 plus 9, which is 45, and the square root of 45 is 6.7. All right, I'm going to stop the video. It's been about 10 minutes, and then we'll figure out what they want us to do with these numbers that we have, because all they ask us is to record its length in the appropriate place on the bottom. So we did that. So all we can do now, I'm going to stop the video, and then we'll read these things and see what they want us to do.